the last video on how we relate the limit of the Riemann sum to the definite integral, we should be able to now take it where if we're given a limit of a Riemann sum, we should be able to express it as a definite integral. Now, in this problem, they tell us that they want to do two things. They want to first take it that a, our lower bound for our integral is 0, and then they want us to do the same thing, but for our lower bound being 2. So at the end of the day, we're going to have some answer where for the first one, it's going to be 0 as our lower bound. And then there's going to be some dx here, but we know that the lower bound is 0. Now let's look at this and let's look at what we have. We know that the limit, and this is the general case, the limit is n goes to infinity of the sum as I goes from 1 to n of f of x sub I times delta x is going to be equal to our integral from a to b of f of x dx. And we kind of want to just like see how everything relates and all these other things. So how does this relate? So what do we have here? We should see that we have it where this delta x just matches with this dx. Now what's delta x in my case? Let's write down what we have in our case, I should say. Limit as n goes to infinity, I goes from 1 to n, and instead of this I have 4 x sub I to the 5th 7 over n. And let's sort of match up. So what we should kind of notice is that here I have it where my function f of x might be 4x to the 5th, right? It makes sense to say that f of x, right, this here is going to be 4x to the 5th, and delta x is the 7 over n. And it's a giveaway if it's over n that it's likely to be the delta x part. So f of x is 4x to the 5th, right? Because if I do, let's say I say f of x is equal to 4x to the 5th, well, what's f of x I? Well, that's just 4xi to the 5th, which is exactly what I have here. So this, right, it makes sense if I call f of x 4x to the 5th. Delta x is going to be 7 over n. So I have delta x is 7 over n. We're going to need that. And yeah, so now what do I have? How do I relate back to this? Okay, so let's fill in what I know now. I know that it's going to be from a to b, but I don't know, maybe I don't know what a is, maybe I don't know what b is, but I know what f of x is. I just found out that f of x is 4x to the 5th. And then dx just stays. But what's relevant is that I need to use this delta x here to get a and b. And once I do that, I'm done. They tell me that the bottom bound is 0, so I know a is 0, so I could further write this out. I could write it as b here, 4x to the 5th dx. And now my key here is that I just need to get the upper bound. I need to get b. And I use the fact that I know what delta x is. Delta x is 7 over n. And I also know that delta x is equal to b minus a over n, where n is whatever it is. And I know delta x in this case is 7 over n. B I don't know. A I know is 0 in the first case over n. This forces b to being 7. And I have my first definite integral for the first case. The first case is 0 to 7, 4x to the 5th dx. And that's part A. Now they say part B is do it for when A is 2. And the only thing that's going to change here is that I'm going to have 2 to B, 4x to the 5th dx. And now I solve this again. I know delta x is 7 over n as well. And I solve this again. but now a is 2. So it's 7 over n is equal to b minus 2 over n. And now I get the n's to cancel again, and I get b minus 2 is equal to 7. 9 is then b. And then my next answer would be from 0 to 9 for x to the 5th dx. And then these are the two answers that they're looking for in this problem.